Good evening, students. I hope
Good evening, ma'am. Good evening, ma'am.
good evening. I hope you all are doing well, and I
Ma'am?
hope you remember the basics and the topics which we had covered pre-lockdown period. Uh, Today, I would be starting the second part of Unit 2. We have completed Unit 1 and Unit 2 half part we have completed during our face-to-face classes. Now I will be starting off. Students, you have to say anything?
Nothing, ma'am.
Yeah, please go
Everything
ahead.
okay.
No, ma'am. No, ma'am.
Okay.
Everything okay.
So, okay, fine. And I have shared important and questions, not important, question bank. I think 100 and some change question bank covering all 5 units has been shared. Did you all receive?
Yes, ma'am. We shared some pics, ma'am. Yes, ma'am. We got it.
Yeah, that's nice. So, today's topic of discussion is file system interface. I would be using slides as well as this scribbling. I would be scribbling some of the things and also explaining you through PowerPoint presentation. Okay, I would be sharing my screen now.
Madam,
Yes.
can you give the access to record this session, please?
Yeah, I have already started recording. I will post in my YouTube channel. I have my YouTube channel in which I post all my recorded videos. I will
Oh,
post in that. I will share the link with you so that you can refer to it whenever you required.
thank you.
Thank you, ma'am.
Yeah, yeah, most welcome. File system interface. It is a file system is a component of operating system. If you recall, file system provides mechanisms for storage and access to operating system and user programs. File system consists of two parts: files and directory. Files stores related data. And directories organizes the files. So this file system is having it's a component of operating system. Second thing, it has two parts. The first one, files. Second one, directories. These files are the structures that stores related data. For instance, a file on excuse me. Sorry for that. Files such as document file, presentation file, which I just opened, PDF file, directory. Directories are the structures that organizes files and provides information about all the files. For instance, this CD PGDCA is directory. In that there is another directory PPTDIR. In these are the files. These are recorded and stored by the operating system in order to um, perform various tasks on directories as well as on files. This part of unit 2 covers this aspect of operating system in which it manages files, directories, creates, read, write, append, access. In other words, provides number of operations on files and directories. And another aspect, if we go down, another aspect which is important is the um, you know partition. Partition is another aspect of file system. You see here, when I explore my computer, this folders, I see these partitions. I have my system memory is divided into C, D, E. These are partitions. This is at a more lower level. In these partitions, we create directories. In these directories, we have files. Partitions are primarily concerned with separating large collection of directories. You see this partition, this partition has a total of 446 GB of memory, and this partition has 627 GB. This one 303 GB. So 1 TB has been split up into 3 partitions here in my laptop, and it varies. You can have 5 6 partitions as well, or you can have just one partition. It all depends. And essentially partitions is used to separate large collection of directories. And within partitions, you will find these are nothing but the directories or the folders. Within folders, you will find folders or files. For instance, in this folder, semester odd, I have these folders and these are the files. If I enter into OS folder, I find these files and folders. If I go into this folder, CD, PGDCA, I find further few folders and files. If I further go into this directory, I find only the files. This is all about organizing and having meticulously arranging the data so that it is convenient for users for operating system to manage and maintain the data. So the first concept, this is the overall idea about this file system. And file system has we will be studying two chapters in today's class, which I am planning. First one, interface with which user interacts. So one aspect is the file system broad aspects. Interface aspect, interface is the one with which user interacts. And the implementation covers those details which are specifically related to operating system, the internal implementation and concrete realization of all the concepts which we users use. So these two, uh, it's like at a lower level of abstraction. When you go down, you will find the implementation details, how each and every concept is being realized, being implemented, being coded, and being maintained and managed by operating system. These two things I am planning to cover. Let us begin with file system interface. Um, File system interface, if you just uh, saw, I have traversed various directories and files, and then I have seen certain types of files. Like here I have these files, ch1.ppt. This is a file. It has got a certain structure, it has got certain contents, and it has got certain attributes, and we can perform operations on these files. And these files are of different types, and they might have different structure, and they might have different implementation. This is how do you identify that this is a PowerPoint file? Because of its extension .ppt. Every file has two parts. The first one is the name of the file, second one is the extension of the file. Here I find only one kind of file. If I enter in this, I go up one level to the parent of this folder. In this directory, I find .docx file, .pdf file, .zip file, .doc file. What are all these? These are different kinds of files, and you can um, observe that when you open these different files, you will find different kind of structure, perhaps, and you can have different operations performed. So then, what here you need to understand is that there are different kinds of files, and every file has a name and an identifier, a unique number which is maintained by operating system, its type, Let me write down. So first one you have file name. First, so in file system structure interface, we are studying file concept. Under file concept, we have file attributes. What are the file attributes? Like every person has got attributes. Every object has attributes. Even file has attributes, which includes name, ID, type, and somewhere you need to store the file. At this point, if you can relate to a physical file or a folder in offices, traditional offices, you will find multitude of files, folders. You can see that every folder will have a number. Folder number 1, another folder number 2, and inside you will find different files. Or it all depends on the terminologies. Here I am talking about big folders. Inside that you will find again further small files. So every file will have ID or name, and you can have different locations. Where are you keeping? Folder number 1 to 10 you might keep in rack 1. 11 to 20 you might keep in rack 2. These rack 1, rack 2 are the locations. Even in computer system, you have location for every file. You have size. Some files are larger in sizes, some files are smaller in size. If you just look at the size of this file, if you open the properties, you will get to know the size. This is 62 KB, and there might be some larger files. For instance, this zip file is 56 or 57 MB. So different size. Every file might have different size. Then you have protection. Protection mechanism includes the rights and privileges. Every file will have some rights and privileges. For instance, I am the owner of the file. If I have created it, I can read, write, execute the file. If I give you permission only to read a file, you can just open it and read it. You cannot modify it. You cannot execute it. So permissions can be given, and then the time and date at which it is created means timestamp is associated with every file, and the user ID of the owner of the file. These are the file attributes. Then what are the file operations? Students, and for any doubt, you can uh, ask, you can interrupt me and ask. So you have different file operations. What may be the operation you can perform on a file? It can be a create operation. It is a write operation you can perform, read operation, you can delete a file, you can truncate a file. Truncate means contents are deleted and memory allocated is deleted, but file exists. You can uh, open a file, you can save a file, you can close a file. All this, if I see here, here I can say new file, open. If further several other operations are performed, those are the basic ones which I have listed out. save as, print. These are different operations we can perform. This is with respect to the interface, means the way user is interacting with it. And further, you have file types. I have already discussed. We have PPT file. We have object file, source file, batch file, Word file, text file, multimedia file. So you have object file, source file, executable file, you have text file, document file, you have presentation file, and so on. File structure. What do you see in this kind of file? You see that there are some headings, there are some bullet points. You may find some diagrams as well, tables. Look at here, figures. Like this. This is the content of this file. If I open some other file, for instance, if I open this assignment or question bank, if I open operating system question bank, you see here this is altogether a different kind of file. You don't see similar structure here. So you understand, structures might differ. What the contents might differ, and system eventually all these files are stored uh, on the disks in the form of blocks. Oh. So you have internal structure. Internal structure is the one which is about how the file is stored inside the disk. You have disk. On this you have tracks, sectors, blocks. You can have like this block and this block and this block, perhaps this block for file 1. So file 1 might get stored on these blocks, and file 2 might get stored on, let me take another color. So if file 2, these are file 2 blocks. This is how file gets stored internally. The next subtopic is access method. This is all about file. And the question that arises is how to access file once it is created, how to access it. So access method. Primarily, there are two ways to access file: sequential access and direct access. Further, you have third type, which is indexed method. Sequential access allows user to traverse or iterate the file, go through the file in a sequential manner, one part at a time. All right. So it will be this. Our file has these 5 parts. Then sequential access means you start with the first one, you go to second one, move on to third one, and you proceed in this manner until you end it. Example, magnetic tapes. If you have heard about magnetic tapes, that supports sequential access of records. Okay, in the file you have records. Consider that this is a file. In this file you have 5 records. So these 5 records can be accessed sequentially, one after the other. And then obviously the advantage is um, that there's no advantage actually. The disadvantage is it is cumbersome and tiresome to access the middle record. If you have to directly jump onto this record number 4, it's not possible until you go through first 3 records and eventually you reaches the 4th record. So this is the problem in this sequential access method. Direct access method organizes a file in the form of fixed length logical records. And then what can be done in this is an example of sequential. The next example is direct. Direct access has a file with fixed length records, record 1, record 2, record 3, record 4, and a user is allowed to directly jump onto the desired record without beginning from the starting record. This is direct. If I specify that read record 3, then I am directly going to read record number 3 without having to go through record 1 and 2. However, here that is not possible. Here you need to start with record 1 and then you have to reach record 4. This is direct method. Direct is random. Indexed method, if I give you example, if you remember, cassettes and tape recorders used to come earlier, a decade or 2 decades ago. At that time, we used to forward and rewind to play a particular song in the tape recorders. That was this one. And then this one is now directly in a computer system. What we can do, open a folder and you can play any song, whichever song you wish. Uh, you can directly start it. So that is direct. Indexed one is you have an index file. This index file contains the details about the records. This is a file. You have file with few records. This is our actual file, and this is our indexed file. Index file. In this index file, this record 1 has an address. Record 2 has an address, and this is essentially similar to direct jump. You give the record number and you get the address and you directly access that record. This is like an index which you find in the textbook. In a textbook you will find a index in which you have topic name and page number. So suppose if you are page number, if you are studying file system interface topic, if you want to know about direct access, then what you can do, you don't have to go to file system chapter and page by page. You don't have to look at the topics and then finally arrive to the direct method. It's not like that. You can with this keyword, you go to index page, get the page number, this may be 450, directly open the 450 page number and get the topic. So that is index file access. This is all about file details, file, its attributes, operations, structure, access methods. Moving ahead, directory structure will be looked upon now. directory structure. The operations which you can perform on a directory is that you can create a file within a directory, you can delete a file, you can list the files and directories present in the directory, you can create a directory, you can rename a directory, you can delete the directory itself. If you again consider this example, here I can say a new folder. If I say new folder, here I am creating a folder, means let me give the name dir directory. If I enter in the directory, here it is empty, but I can create a new file here. I can create a new file, I can create a new directory as well. I can create a text document, for instance F1. This is a file that has been created in directory dir. The directory structure can be at single level directory. When you have single level directory, you have uh, one directory and all the files are contained in the same directory. All right, you have only one directory and all, so for instance dir, in that you will find all the files, all files are stored in this directory. Two level directory structure, two level, which implies that you have a directory which you can call as a parent directory. In this you can have child directories. These are parent directories, child directories. In these parent directories, you can create any number of child directories or files. In child directories, you can have 5 files. This is two level structure. And then you have a tree structured directory. Tree structured directory wherein the limit is not imposed on the number of levels. You have this root directory which is further divided into or have subdirectories, subdirectory 1, subdirectory 2, which can further have sub directory 1 or file 1 and file 1 and so on. This is a tree structure. And you have another structure which is acyclic graph. In a tree directory structure, if you have to have this F1 to be accessed from this directory as well, in that case, you have to have this F1 located here also. Acyclic graph structure. We are going. Are you coming with us? Excuse me, students. Sorry, students. So, acyclic graph. In this, what happens is you have the similar structure You have root directory, you have subdirectory 1, subdirectory 2, subdirectory n, and then if there is a file f1, then this subdirectory 1, 2 can have a link. There can be a link. There is only one file which is being linked by two directories, which avoids having multiple copies, and then saving the storage and other advantages. Okay, and finally the fifth structure is the general graph structure. General graph directory structure is about having um, you know a structure in which you can have cycles as well. So primarily here you have root, subdirectory 1, subdirectory 2, and so on, subdirectory n, and then you can have subdirectory 1, and then you can have cycle also. Means you see here there is a cycle being formed here. In other structures you cannot have cycles, whereas general graph structure can have cycles. Okay, this is about directory structure. Uh, Moving on to the next topic, which is file system mounting. File system mounting is a concept that facilitates merging of two or more namespaces. Mounting is nothing but merging here. So what happens? Um, if you see here, I have um, um, in my PC, I have three partitions. If I insert a USB, then what happens? I get another partition here. Partition in the sense that I get a link uh, through which I can access the files and directories contained in that USB drive. Or if I place a CD or DVD in my DVD drive, I get here again one more, which allows me to to have a glance over the files and directories in that DVD. So what I mean to say here is that here we are merging. Here this under a root, if we have three partitions, if we are going to add further two more, that is nothing but sort of mounting. Okay, so mounting is nothing but merging of two or more namespaces. And what happens is uh, this if this is our root, here we have partition 1 or partition 2, and suppose there is another partition 3 which I would like to get mounted here, at this, and consider that this is also a uh, file system, then this we can attach to this one. Here I am mounting. It is set to be P3 is set to be mounted here, and the location where this new file system or a partition is being attached is known as mount point. To mount point, we are merging or mounting in a new partition or new namespace. Generally, it is a namespace. This is mounting. Next, next topic is about file sharing. What happens is when multiple users are collaborating and working in a team, they need to share files. In you know generally if for a file there are three kinds of users. There is an owner, there is a group, and others. These are the three categories of users, and these three categories of users designate uh, the different permissions or privileges attached to these categories. Owner is the one who creates the file and who has all the access permissions. Group is the one to which owner belongs. Suppose if hmm, suppose if I am the user HS, I have created one file F1, and my group name is say OU, and in this OU I am one of the member, and there are other members, for instance RZ and PS, AB. So these are the group members of OU. They might have got a specific set of permissions. Others are all the other users, public users, the public. So the files will have permissions based on to which category a user belongs. And there is a concept of having the access to the file which is residing at a remote location. Okay, so remote file access. For that, there is a remote file system, which is under this. I'm talking about file sharing. This is the main topic. In this, I have discussed about the file users, and now accessing the files through remote file system. And networks allows sharing of resources over the network. You can create a file, you can do various operations on some other computer which is not located at your place. That is possible through distributed file system. Okay, this remote file system, nothing but accessing or performing operations on files residing remotely. That is facilitated through distributed file system. There is a file system which resides and manages only the files on local machine. Distributed file system is the one which spreads across multiple machines and which manages the files uh, across multiple machines, not uh, not on single machine. For instance, this is my laptop. I have one file system in my laptop. I got this file system because I have installed Windows 10. I have Windows 10 operating system, and Windows 10 operating system has got its own file system, and this one is managing the entire file structure in my laptop. For instance, if I have created a distributed system with some of my friends who are geographically apart. For example, I have my friend RZ and TS. These are suppose one is in US, one is in UK, and we three would like to have one file system, only one file system. Then we can install a distributed file system here. This distributed file system manages all the files that are stored on all the three machines, not on a single machine. This is about distributed file system. And in this distribute with respect to a remote file system, you also need to understand client server model. You have client server model where there are servers and there are clients. Servers may store millions of files, and clients access those files through request. And obviously these are geographically apart, and they have to have a remote file system or a distributed file system. Then you may have different semantics associated with distributed file system. It's not same as it occurs in local file system. In local file system, if something fails, we get to know, and then we will resolve that issue, and then we will access the files again. But suppose in a distributed file system, if something fails, problem occurs, you need to identify where the problem has occurred and how are you going to resolve it, and what are the consistency semantics. So you need to have failure mechanisms, you need to have consistency semantics, which implies that how are you going to reflect the changes which you are making in a file which is accessed by several other users. The gist here is that distributed file system is relatively complex and requires more features and functionalities compared to a local file system. And finally, the last topic in this chapter is protection. Protection is all about keeping the information confidential and safe from physical damage or logical damage, and protection of files uh, mainly concerned with what kind of access mechanism or permissions you are allowing other users to have with. Suppose if I am the user, and if you're my friend, and if I trust you, I may give you all the permissions for a file, say F1. Whatever operation I can perform on F1, my friend can also perform on it, because there is a trust here in this case. In case that I give the same level of permissions to the public, to everyone, F1, and if suppose there is an evil person in this public, and if I say that anyone can modify the file, and if it contains some important information, that evil person may modify it and can change it, then what my job is? My job is to protect this file, and I have to control the access provided, by limiting that access to these files based on uh, read, write, execute, append, delete, list, what permissions I am assigning to this public or to this group or to my teammates or to my boss. It all depends on the type of user. And this one mechanism which operating system makes use of is known as access control list. Access control list, ACL in short. This has a scheme in which it maintains a structure that has where you have objects along the x-axis and you have users along the y-axis. So if I have file 1, file 2, file 3, if I have user, HS user, RZ user, TS user, some AB user, HS user can perform all the operations: read, write, execute. So I am listing read, write, execute all operations for F1. This RZ can perform read and execute only on F2. And HS can perform only read on F2. And likewise, you can fill it up as per the user and the objects. So based on this access list, if I try to access a file F1, and if I am HS, if I have been authenticated and have been identified that I am HS by entering my username and password and by having access to the system, if I try to open F1, then what does it do? It refers this list and find out what permissions I have, because I can do anything. I can open this file, I can read the contents, I can write to that, I can execute it. And similarly, when I try to open F2, I cannot write and execute. Means these two operations are not supported for HS user. Like this, files are safeguarded, from intended or malicious um, harms or modifications. All right. Other access control mechanisms or protection mechanisms include having a uh, password to a file or a directory. You can have a password associated with a file, and if me, HS user, try to open F1, if I enter the password, only then I can access this. Otherwise, I can't access. This is also a protection mechanism. This is all about file system interface chapter. Any doubt, anything which you have not understood, please ask me. Before moving ahead to the next chapter, which is file system implementation, let me clear your doubts with respect to interface. If it's okay, please respond. I'm saving this and I'm sharing with you all. I'm creating PDF file out of my writings, whatever I have written. Babes, can I read this? Yeah. First. No, I want another one. This one. Okay, all right. So this is please respond in chat window. Oh, okay. No problem. I will create PDF files out of all this, and I will share with you. I'll share with somebody, and I'll ensure that you get in your group. You have WhatsApp group, right? So you will be getting in your WhatsApp group.
Okay, ma'am.
Okay.
Thank you, ma'am.
Sure, ma'am.
All right. So next, this one is file system implementation. I think someone is on unmute. Please mute your mic, all of you. Okay, right. We know that there is a disk. There is a disk which has a huge amount of storage in the form of platters, tracks, cylinders, sectors. Okay, so if you look at here, this disk, and this is our main memory. So our file system, um, file system itself is a collection of programs, right? That maintains files and directories that reside somewhere here. I can say that this part is our file system. This is our file system. So what happens here? This file system has a permanent place in the secondary storage, hmm, which is disk here. This is the permanent place for a file system. And then what happens is this file system can the parts, the programs that make up this file system can be brought into RAM, or the files that are stored on the disk can be brought in this memory. So, transfer takes place between memory and disk. You can bring it from the disk into memory, and then you can save it back into a disk. So this kind of operation happens, between disk and memory. And this file system can be moved in units of blocks. Uh, as a matter of fact, even any file or directory, whatever you are bringing in, as a unit of blocks, where each block may be, consider that this is sector. Okay, this I have made this partitions. Consider that these are sectors, and you have tracks, number of tracks and sectors. So number of sectors together form one block, and number of blocks can be brought in or brought out. And file system is stored permanently on disk. And this file system is composed of different levels of um, programs or operations. At the top level, what do you have? You have application programs, which users create application programs. Okay, and then these application programs, through logical file system is the one which user access. And under logical file system, there is a file organization module. File organization module is the one that keeps track of organizing files. Okay, keeping at one place and bringing. And then you have basic file system. Basic file system is the core of the file system that implements the basic functionality. For instance, creating, deleting. Further down the line, you will find IO control. This IO control is concerned with input-output operations with respect to files. Finally, you have device. If I say that I have hard disk, so hard disk is at this level. From this hard disk level up until application program, these are the intermediaries which perform their specific tasks to make the task of user simple. We just say, here I can say insert or home, or here I am saying add page, here I am saying add section. But eventually, when this page is being added, memory has to be allocated. Where? On the disk, because this gets stored on the disk. All this I'm not concerned with. I'm just concerned with adding a new page option. I am choosing this option and I am getting a new page. But there are number of tasks that need to be performed through all the levels until it reaches the final disk level. So file system has all these components, subcomponents we can say. So here let us look at an example. If I say here open, if I try to open a file, to open a file there is a file control block that has to be read by the operating system, which will uh, you know translate the logical address to physical address. I am trying to open the file with the name, but then on the disk it has got some location. So that is the physical address. This logical address has to be converted to physical address, and then you have to generate the commands. This whole this part is being dealt by this file control block. Then here you generate commands to the device drivers, generating command. This basic file system generate commands. What commands? We say open, but internal implementation of open might perhaps have several system calls that is being done by basic file system. Apparently our device drivers, if you might have heard about device drivers, those are the programs that directly interact with the devices. So these device drivers resides at this IO control level, which will interact with the device directly. This is how the complete process is in order to access a particular file. I just say here, I can say here open. When I say open, I am trying to open a file with the name which I have given. Okay, but then this will have some location. This will have some address, physical address, and then a particular device on which it is stored. All that is handled by this file system by going through various sorts of layers. Next is file system implementation on disk. On disk, what does file system means? A part of file system permanently resides on disk. Is there only. Um, we have got information about how to boot an operating system, and then the total number of blocks on the disk is number of blocks. Then number and location of free blocks means some of the blocks might be occupied, some might be free. So how many blocks? This is the total number of blocks. This is total. Then number of blocks which are free. The number of blocks which are occupied is allocated. Then directory structure. What is the directory structure? And what are the individual files? This all information is contained in a file system. Means file system must know Like, for instance, a principal of a college must know how many courses are there, how many programs are there, how many degree programs, UG, PG, faculty members, and what is the infrastructure, what are the resources available. Everything need to be known by the administrator in order to run the institute effectively and efficiently. Likewise, file system is an administrator of all the files and directories. File system has to know uh, everything related to the storage and files, and also it has to have information about, okay, how to boot. When you switch on your system, what happens is operating system gets loaded. Here you see operating system actually resides on disk. Say this is our operating system. Here operating system is residing. Where operating system is residing? How to transfer this operating system from disk into memory? That is all known to this file system. And this boot control block on the disk, there is a block.
We are not able to hear you, madam, properly. Please be a little bit louder.
Oh, sure. Hello. Yeah. So, um, I'm talking about a boot control block. Wherever the operating system is stored uh, on the disk, that is known as boot control block. So this boot control block contains the information uh, on the, uh, you know, no, wait. Here operating system is stored. Here file system is stored. In the file, within file system, there is a block known as boot control block. This boot control block uh, is the one that contains information on how to load an operating system. And then there will be a block known as partition control block, PCB. Partition control block contains partition details, like how many partitions are there, how many blocks are there in each partition, how many free blocks are there, and all, and so on. And there is also a directory structure here. In this file, we are talking about file system here. This file system, consider this part. This may contain directory structure that it keeps information about how many directories are there, what is there in each directory. Then you also have a file control block structure stored in directory, because files are stored in directories. These are the primary blocks that are stored in a disk with respect to the file system on disk. And this boot control block in Unix operating system is known as boot block. Okay? And a partition control block in Unix operating system is known as super block. All right. So these are the structures that reside permanently on disk. And then within directory you have further file control block. It's not within directory; it is also on control. So you have another component is a file control block, FCB. Then this FCB keeps track of how many files are there, where they are stored, what is the size of each file. Everything about files are stored in this FCB. And this Unix file system calls FCB as inode. Alright, is this concept clear? This is all about the file system residing on disk. There are 4 components: boot control block, partition control block, directory structure, and file control block. And in Unix operating system, boot control block is known as boot block, as PCB super block, FCB inode. Boot control block keeps track of about the information on how to load an operating system, where an operating system is stored, and so on. Partition control block has details about how many partitions are there, how many blocks are there in each partition, and so on. Directory structure records information about how many directories are there, where they are stored, what are their sizes, and so on. FCB file control block has details concerning to each and every file. Alright, this is the file system residing on disk. Okay, files information. So file system implementation has on disk structure and in memory structure. On disk we have 4 components: boot control block, then partition control block, then directory structure, then file control block. In memory, now we will look at in memory structure. And in memory structure includes, this has an in memory partition table, and then it has a direct in memory directory structure. Then we have a system-wide open file table, system-wide across the system, system-wide open file table, and finally we have per process open file table. Alright, so how this works in memory structure, in collaboration with on disk structure. Let us look at. Suppose a file has to be opened. Okay, when you have to open a file, file open. The process goes like this. The user says open and file name. This is at user level. Then you have in, this is in memory table, which is directory table. If suppose this file is located in this directory, then here on disk you have a directory structure which contains blocks, and you have these are these are directory. This entire thing is one directory, for instance, and in each directory you have a file. This each one is a file, and this one is FCB, file control block. When user try to open a file, first by looking into the directory structure, in memory directory structure, operating system will determine in which directory it is. and then it goes to that directory and then reads the file control block of this particular file, say F1, and this is F1, and say this is F1. Then reads that, and then operating system will return this to the user. This is how file will get open. This is on disk structure, and this is in memory, and this is user level. Okay. Next one is for instance, if you want to read a file read, you want to perform a read operation, then what do you have to do? You say here, user will say read what part of file you are reading. You can provide the index of that, and then in memory you have two tables which are per process open file table and system wide open file table. So this user per process means user executing a program. Program is a process in execution. So every process that is being executed, for every process you have a process table. Per process pp per process open file table. Okay. So first it is seen where it is in per process, that, and then read this part, and then go to on a system there may be several users, there may be several processes, right? So this table is with respect to one particular process. In this system uh, wide open file table, you have so many uh, you know um, entries, one for every process. So after you get to know about this, then what happens is, on disk also you have a structure, right? So on disk you have FCB. Suppose you are reading F1 first part. You are trying to read the file one, in other words, and these are the blocks with respect to file one. For instance, one F1 has 4 blocks. So this is our F1. It has 4 blocks. So user will have, every process will have a per process open file table, get the information about this file, look that into system wide open file table, and from there find out the FCB. What this FCB contains? This FCB contains the location where this F1 is located. So you go to that F1 and start reading it. This is how file read operation is performed internally. You just say open and you start reading. Internally, it has to go through this process, and these are the structures that are maintained by the operating system and file system. I hope that this one is clear. If not, you can please ask. And moving on to the next topic, which is how to implement this partition and mounting. Partitions and mounting. So you know that a disk can be partitioned into multiple segments or portions. Okay, each portion may be called as a partition. And then each partition, suppose this is our disk. This disk, you can partition it into 3 parts. This is C, this is D, this is E. Okay, and this partitions, you can have a raw partition, or means okay, yeah. A partition in which there is no file system, there is no information about that you can use for DBMS or for RAID. Here everything is maintained about the C partition and D partition, but E partition may be raw. Raw partition means which is not formatted, which is not divided, which is not worked upon, so that some other application can create and develop it in its own format and pattern. So you can have like multiple partitions. Partitions can be cooked or raw. Cooked means you have a file system associated with it. Suppose this C and D are cooked, means there are file systems. E is raw, there is no file system. And then you can also have a partition for boot information, and you can have dual booted system in which you can have multiple file systems. If you install multiple operating system, obviously you get multiple file systems. So you can have multiple file systems, and then you can perform this partitioning, you know, multiple ways as per your needs. It's not fixed and it's not defined. All right, this is about partitioning. Means cooked, in this cooked, raw, boot partition, and so on. And then you can perform mounting of these partitions. You can perform manually or you can perform automatically. So you can mount C and D at one level, to its root. This mounting E, for instance, you can say that CD is performed automatically, E you want to perform manually. There may be commands which you can use in order to mount the partition, manually, means by executing the commands. So mounting can be done automatically or manually at boot time or later, uh, depending on the operating system and depending on the user requirement. This is about partitioning and mounting. The last concept in this chapter is virtual file system. Virtual file system is essentially required in order to support multiple file systems. What happens is you have uh, here you have multiple disks. This can be over network. You can even remote connection can also be established. So let us consider this to be network. This has its own local file system. This disk has its local file system, and this one is remote file system because it is accessed through a network. And all these you can access by means of a virtual file system interface, VFS interface. And on top of it, you will find a file system. essentially when a user, here there is a user, this user would like to access files from this, say L1, or from L2, or over the network. These two are actually locals, and over the network, say N1. This user would like to have same interface, same interface. If this is Windows and this one is Unix, the way you access Windows file might be little different from the way you access Unix files. Commands might also differ. In order to have a unique, common common file system interface, you can go for a virtual file system. In a virtual file system interface, this user will issue a command. If suppose there is a command to create a directory mkdir or just mk. For instance, in Windows you have just mk, in Unix you have mkdir, consider. Then user has to know these two different to work on this, and suppose on network it is something else, say mkd. This is on network. Instead of having all this, what we can have a common interface wherein user specify that user would like to create a directory at a higher level of abstraction, create directory, and this virtual interface will take care of the intricate details related to these file systems, different file systems, and thus the access becomes easy and simplified. All right, this is about Unix file system. Students, do you have any doubts? With this, we have completed our file system implementation also. So we have completed 2 units. The second unit, first of 1.5 already completed. Now I have discussed 2 chapters. So 2 units have been done. Tomorrow I'll start with a very important topic known as process synchronization, which is unit 3. Any doubts in today's class?
No, ma'am.
Is everything clear?
Yes, ma'am.
Okay, then I will share the PDFs of my whatever I have written, and also the lecture, this YouTube link, perhaps tomorrow, or by today evening or tomorrow. Okay.
Thank you,
Okay.
ma'am.
Okay, then bye bye.
Bye.